What's up, my people? After watching this video, you will be able to graph a rational function with a constant or linear over a linear. Let's get it.
Yeah.
To start, let's go ahead and look at some vocabulary. From the degree, you can determine the leading term and also the leading coefficient. Here are some examples. An asymptote is a restriction on the function. The vertical asymptote exists where the denominator is equal to 0, and your horizontal asymptotes have a few options. If we have ax to the n divided by bx to the m, if your degree of your numerator is less than the degree of your denominator, then your asymptote is going to be at y equals 0. If your degrees are the same, then you look to the coefficients and you just take the a divided by the b. And if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Okay, so here's our first example. We have f of x is equal to -5 divided by 4x minus 10. First, we need to find the vertical asymptote. The vertical asymptote again can be found by setting your denominator equal to 0. So here's what we do. We do 4x minus 10 equals 0. We add 10 to both sides to get the x by itself, which will give us 4x is equal to positive 10. We divide both sides by 4 and reduce the fraction, which will give us x is equal to 5 over 2. Our horizontal asymptote comes again by looking at the degree of the numerator and the degree of the denominator. Because the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is going to be at y is equal to 0. So we'll go ahead and graph. So at 2.5, we have 1, 2, let's say that's 3, so a half would be right here on that line. So here's where we have our vertical asymptote. Then we have our horizontal asymptote at y is equal to 0. Since we're dealing with x is equal to 2.5, I'll do 4, 3, 2, and 1. So if I plug in f is equal to 4, or f of x is equal to 4, that means I'm going to substitute all of the x's for 4's, which will give me -5, and then we have 16 minus 10. 16 minus 10 is equal to 6. And that would be -6 over 5. So our first point would be at x is equal to 4, comma, -5 over 6. If we substitute x is equal to 3, we'll get -5 divided by 12 minus 10. When we simplify that, we'll get -5 divided by 2. So our point will be, again, when x is equal to 3, our y value will be -5 over 2. When x is equal to 2, I'll substitute in the 2 in for x. So that's going to be -5 divided by 8 minus 10. When we reduce that, that's going to be -5 over -2. Negative divided by negative is positive, so that's going to be a +5 over 2. So our point when x is equal to 2, our y value is going to be 5 over 2. And lastly, when I plug in the 1, I'm going to get -5 divided by 4 minus 10. 4 minus 10 is -6, so that's 5 over -6. Negative divided by negative is positive, so it's going to be 5 over 6. And the point will be when x is equal to 1, my y value will be 5 over 6. So now I will plot these points and then we'll join them in a curve. So when x is equal to 4, our y value is going to be negative 5 over 6, which is approximately or really close to negative 1. So again, because this is a sketch, I'll be sketching. That seems to be very close to negative 1. Again, when x is equal to 3, I'll be at 5 halves or negative 5 halves. So it'll be right about here. When x is equal to 2, I'll be at 5 halves. So I have to go up 1, 2, 3, and halfway between that. So that would be right around here. And then when I have 1, I'll be at 5/6, which again is very close to 1. So that would be right around here. So when you're graphing and you're dealing with the asymptotes, your line is going to curve and it's going to run parallel with the asymptotes. So this line, again, this is a sketch, so please don't judge me, don't hurt me. Like this. And like that. And similarly, like that. And that's our first example. Let's get to the next one. For our next example, we have f of x is equal to negative 2x minus 3 divided by 2x plus 5. Again, to find the vertical asymptote, all we need to do is set the denominator equal to 0. So we have 2x plus 5 equals 0. We'll minus 5 from both sides, which will give us 2x is equal to negative 5. Divide both sides by 2. And that means that our vertical asymptote is going to be at x is equal to negative 5 over 2. Our horizontal asymptote asks us to check for the degree of both the numerator and the denominator. The degrees are the same, so that means that we look to the coefficients. So the coefficient is going to be negative 2 divided by 2, which gives us negative 1. So our horizontal asymptote is going to be at y is equal to negative 1. So we're going to go 1, 2, 3, and go halfway between that. And then our horizontal asymptote is going to be at y is equal to negative 1. Since we're dealing with negative 2.5, I'm going to be plotting negative 4, negative 3, negative 2, and negative 1. So when I plug in x is equal to negative 4, then I'm going to get negative 4 over here, negative 4 over here. Negative 2 times negative 4 is positive 8. So that's going to be 8 minus 3 divided by negative 8 plus 5. When I simplify that, I'm going to get 5 over negative 3, which will be negative 5/3. So that would be when x is equal to negative 4, my y value is going to be negative 5/3. When I plug in x is equal to negative 3, I'm going to get positive 6 minus 3 divided by negative 6 plus 5. 6 minus 3 is going to be 3. And negative 6 plus 5 is going to be negative 1. So that will reduce down to negative 3. So we have negative 3 comma negative 3. When I plug in negative 2's into the function, I'm going to get a positive 4 minus 3. And then we're going to get a negative 4 plus 5. 4 minus 3 is 1. Negative 4 plus 5 is also 1. So that's going to be 1. So at x is equal to negative 2, my y value will be 1. And then when I plug in negative 1, negative 2 times negative 1 is positive 2. So that's going to be 2 minus 3. 2 times negative 1 is going to be negative 2 plus 5. When I simplify, that's going to be negative 1 over 3. So now we'll plot these points. So at negative 4, we'll be at negative 5/3. Negative 5/3 is approximately negative 2. So that would be somewhere close to here. When I plot negative 3, I'm going to be at negative 3 as well for that point. At x is equal to negative 2, my y value will be 1. So it should be somewhere around here. And when x is equal to negative 1, I'll be at negative 1/3. And similarly, this one will go like this. And there we have it. All right, we're at that point. Here's a problem for you to try. There will be a link to the solution in the description. Please like, share, and subscribe for more tutorials. Thank you for taking the time to invest in yourself, making a weakness a strength. Ashe.